Hi everyone, welcome to today's Worldwide Show webinar. We have as our guest presenter today Peter Kuhn, who has delivered already several webinars for Worldwide Show. The topic of today's webinar is unit testing for Windows Phone 7. And as usual, this live session will continue for about 60 minutes. At the end of this session, we'll have a standard 10-minute Q&A session where all questions we got will be replied by Peter, for as long as we have time, of course. So if you have some questions during the session, feel free to submit it using the chat option in your webinar panel. And at the end, all questions will be reviewed and answered. Okay, so Peter, can we start?
Yes, of course. Thank you, Svetla. Okay. And thank you all for joining today. I hope you enjoy the webinar today. We have a lot of things to talk about today and a lot of code to show. So I will only give you a quick introduction about me. My name is Peter Kuhn, and you may know me as Mr. Good Cat. And you can read all the details about me and how to contact me on the webinar page or after the webinar. I will just skip the details here. Today we are going to talk about unit testing on Windows Phone. And I have a bit of a difficult task to do today because I know that some of you have not much or no experience with unit testing at all. But on the other hand, this webinar is meant to be for people who already have some experience with unit testing and who want to learn about what they need to do to make unit testing work for Windows Phone. And I will try to cover both topics today, so I will give a very quick introduction to unit testing itself, which may be boring for those who already have some experience. And later on I will dive into more advanced topics which may be too much for those who have not any unit testing experience at all. I hope you still all stay with me throughout the webinar, because in the end I will have a maybe 10-minute demo of a real cool advanced feature that I think will be interesting and fascinating for most of you. Okay, so let's first talk a bit about unit testing itself and what unit tests are and why we want to unit test our software and our applications. The obvious goal we want to achieve is to increase the trust in our own code. So we can introduce code changes and add new features to our code easily and reassure that all the features we have implemented so far still work as expected. So unit tests help with that in a way that allows us to automatically, in an automated way, test our software, our components, and discover defects and bugs that we introduce into our code as early as possible. One of the criteria that's very important here is listed here is the bug fixing costs, because the earlier you detect a bug in your code, the cheaper it is to fix. For the phone, for example, imagine that you have submitted your application to the marketplace and your customers find a bug in your application. Then this will be very costly to fix, because not only do you have to go back to your code, find the bug, fix the bug, test if the bug is really gone, you also have to go through the submission process to the marketplace again. So this means that your customers will have to live with this buggy application at least for 2 or 3 days, maybe a week, until a fix can be released. So if you are able to detect these bugs early on in your testing process, then this will be much cheaper to fix. And a lot of people don't think of unit tests like that, but they also can be part of the documentation of your software and documentation of the design of your software. For example, imagine a new developer that is joining your team and working on your code, existing code, and instead of pointing them to documentation that is written in free text, or instead of letting them work on the code right away, you can point them to the unit tests, and when they take a look at the code, at the test code, they can see how a component is ought to be used, what the original developer had in mind, how they wanted the code to be used, what error conditions can occur, and things like that. So this also can simplify the introducing new developers to the project, and of course be documentation for your code. What you have to one thing or things that unit tests are not is they cannot show the absence of errors. They only can show if a test is in an error state. So if all your tests are successful, are running successful, this does not mean that you don't have any errors in your application. It just means that everything you test does not result in error conditions. So one of the important things is to therefore test the right things in the right way. And of course, unit tests also require quite some work, because they must be maintained. This is not a one-time thing that you set up and you benefit from for all eternity. You must live this process and add new tests when you add new code, or if you do TDD, you add new tests and then write the code for these tests. Either way, you must maintain these tests, and you must also execute these tests frequently and do reviews of failing tests in a timely manner. Or otherwise you will see that you do not benefit a lot from unit testing at all. So what should your unit test look like? I have written down a few points here. First of all, you should always test a single piece of code, which is the unit part of unit testing. This sounds rather easy, but we will see in the live coding session in a few minutes that it's one of the hardest things to do, especially for beginners. Then you should test a single functionality. Write a single test for each functionality you want to test. Do not put like multiple assert statements into one test, for example. There's quite some discussion about this, but the essence usually is that if you do that, you violate some principles of unit testing, that, for example, unit tests should be simple, that it should be easily visible what the reason for a failed unit test is without having to debug, for example, a test. Then make sure that you test your own code. I've seen unit tests that test the outcome of calls that go into the .NET framework or external libraries, and there's really no sense in doing that. You should only test your own functionality, because we need this basic level of trust into the .NET framework and the libraries we use. Usually there's nothing we can do about bugs we find, or if we find bugs, there's usually nothing we can do about that anyway. We can only work around that, and the .NET framework will not change, so only test your own code. And then my personal opinion is that you should start with testing what you gain the most benefit from. A lot of people measure the quality of tests by code coverage, for example, by the amount of code that is covered by tests. I personally do not do that, because I think that in every project there is code that is not important to test. For example, static classes that are only data containers that will never change over the lifetime of a project, or very simple configuration classes that only hold some values that are loaded once at startup and never change through the lifetime of your application. Things like these, in my opinion, are less worthy testing than more complex logic, more central parts of your projects, components that you know change frequently. So, for example, state machines, calculations, nested conditions are listed here, things that you know are crucial to the functionality of your application that you know will change in the future and features will be added to in the future. These are the things that you should focus on. And then, of course, like what was written in the previous slide, you should make sure you test the right things in the right way. And we will now dive into the live coding and see how to set up unit testing for the Windows Phone, write some simple tests, or maybe only one simple test, and see what makes this test good or what are not so good details in testing. Okay, so let me switch to Visual Studio. I have created a really small sample application, which is a calculator, and I've seen that a lot of people use calculators for demonstration of unit testing, and I apologize for using a calculator too, but I'm not creative enough to think about more or better examples here. So this calculator is really simple because it only supports addition. We are able to enter two numbers here and hit the compute button, and the calculator spits out the correct result, hopefully the correct result. The code to that sample application follows the MVVM pattern, although it does not depend on any external dependencies. I have not used any external frameworks for MVVM here. I have also not implemented any commands, for example. A very simple MVVM-like application that focuses on only what we need for the unit testing part. So we have a view model here. That is the view model for the main page that exposes a few properties that are used for the binding, for the UI binding. It also has a method that does some validation on the input numbers, and it internally uses a calculator that does the actual computation and makes sure that the UI can receive the result of this computation. I have deliberately made this validation method not very good, so if you play with this sample later, you will have a lot of possibility and a lot of opportunities to write tests against this validation, for example, and make them fail, make the tests fail, and practice your unit testing skills with this code. The calculator class itself is extremely simple. It only has one method that adds two arguments and returns the sum of it. Okay, so when you want to start unit testing an application like that in a traditional desktop application, what you would do is you would simply go ahead and add a new project that is a test project. This is a .NET class library that is pre-configured for unit testing, and it's amazing that to a certain extent this would work. You would receive some warnings if you try to add references to your Windows Phone application to this test project, but to some extent this would even work and you would be able to write basic unit tests. But of course, as soon as you mix in any Silverlight specific elements or even elements that are specific to the phone, you will not be able to test them because you're not able to reference the required phone assemblies. So we need to find another way to do our unit testing for phone applications, and the most common, the obvious way to do that is to use the unit testing bits that are located in the Silverlight toolkit. Now, a guy I'm sure you know, who is named Jeff Wilcox, provides modified versions of the Silverlight toolkit assemblies for unit testing that have been built for testing Windows Phone applications. You can find these assemblies in Jeff Wilcox's blog, and I will post links to all of the resources I'm talking about in this coding session at the end. And what you have to do is you have to download these two assemblies, and then you can set up the unit testing part for your Windows Phone application. So the workflow to do this is to create a second Windows Phone application next to the one that you want to test. Let's name that sample calculator.tests.phone. And this will be the application that performs the actual tests. So what I do is I use these two assemblies that you can get from Jeff Wilcox and add references to them. And I will also add a reference to the sample calculator project I want to test. Yeah. Okay, so this is the setup you have to do regarding the references. And now what you will have to do is you will have to set up something that is called the unit test page that is able to perform all the unit tests that you will add to this project, and that will be able to show the outcome and the results of these tests in the emulator. So the idea behind this is to launch this test application. This test application has access to the actual application you want to test, and the outcome of these tests are then displayed directly in the emulator where the actual testing happens. There are some steps to perform here. I will add a link to a resource, to a cheat sheet that describes these steps in detail and what the idea behind this is. But for now, I will simply show you what you have to do. First of all, we hook the loaded event of this main page. This page is not needed, but it's the entry point of this application. And what we will do is we will use the unit testing framework, create the actual unit testing page, and replace the current main page that we do not need with this unit testing page. And one thing I will add is I will disable the system tray to get as much screen space as possible. So basically there are 3 steps to do. First, we create this actual unit test page, which is done by using a static method in the unit test system class, and that is named create test page. And this returns a UI element which we can cast back to an interface named iMobile test page. So this basically is the setup of the test page, and what we do now is we replace the current main page of our application, of this test application, which is the main page we are currently working on, with this unit test page. And there's one final step to perform here. When you navigate through the results of your unit tests, you can drill down into the individual test classes and test results, and to go back up these levels that you drill down into, you have to override the back key press, the key press of the hardware back button, and tell the unit test page to navigate back. And so the idea behind this is we override, or we hook this back key press event and say, okay, when the user hits the back key, we simply pass on this request for a back navigation to this iMobile test page, and if the page has something to navigate back, it will return true, and we say, okay, in that case we want to cancel the actual back navigation. If you don't fully understand this, that's no problem. I will run the test application in a moment, and you will see what this means when the application is run. And now I can go ahead and add unit tests to this application. I like to structure my unit tests in the same way like the original application that I want to test is structured, which means when I want to test, for example, the view models, I will, or the main page view model, I will add the same folder structure and a class that is named main page view model tests to the project. Okay. And what you have to do is, if you're not familiar with this, you have to decorate your classes with a test class attribute, so the unit testing runtime can discover these classes. Every class that is decorated with this attribute will be used for to execute the unit test contained in that class. Excuse me. And every method that represents a test will needs to be decorated with the test method attribute. And regarding the naming conventions for unit testing, I follow a common pattern, a recommended pattern by a lot of people, and that is I split the naming of my test methods into 3 parts. First of all, the part I want to test, which, for example, is the compute method. Then the conditions I want to test this compute method under, which is using 2 valid numbers, and then the expected outcome of this test. The correct result is computed. Okay? So everybody who wants to understand this test can simply read this as if it was a normal sentence. I want to test the compute method using 2 valid numbers and expect that the correct result is computed. Okay. And the way to do this is that you simply go ahead and create the object you want to test, which is the main page view model. And then we have to set the parameters we require for this test, which is, for example, the first number, the second number, and after that we invoke the this is the setup part of this unit test, and now we perform the action that we actually want to test, which is the compute method. And now we inspect if the result is what we expect it to be. And this is done using the assert class, which has all these nice predefined methods that allow you to make sure that values and property values, objects, and so on contain the values that you expect. For example, we want to make sure that the result property of our view model contains the value 2 after this operation. Okay, so that's a very simple unit test, and I will run this now and demonstrate you what this looks like in the emulator, so you get an idea what the unit testing, this unit testing test app looks like. Oh, sorry. I started the main application. Of course, I want to start the test application, not the main application. And when you do that, let me just disable this timer, you're presented with this main screen here. This is the unit test page that we set up in code in the main page code behind file that replaces the actual main page. And what this does is this allows you to run all the tests that are located in the test application, or you can also use a tag. You can tag your test methods or test classes with certain terms, and then execute groups, ranges of tags to only execute a subset of the tests that you have in the test application. For example, if you're only working on a specific detail, or if you have so many tests that the runtime that they require too much time to run, you can only run a subset of that. We run everything, and that was really quick, and you can see down here that your code looks good. You get the statistics that one test has passed, and you get a list of tests that have been executed here at the top. And this is the drill down feature I was talking about before. You can now drill down into this main page view model tests class, which is our class here. And now you see the list of tests that are contained in this class, which is only one at the moment. And if you drill down further, then you get the results of this test. Okay, and what we did when we did override the back key press is this allows us to go back one level to the class and another level to the whole assembly here. One drawback you can see already is that this screen size is so limited that it cuts off the method names here, and it also does not support landscape mode, so you cannot fix that by rotating the screen. That's a bit of an annoying detail, especially when you use a naming convention like I do. We will see how to work around these things in a moment. Now that you have a basic idea what you need to do to set up unit testing directly on the phone, I want to take a step back and talk a bit about whether this is a good unit test or not. And I think when I ask the question in this way, you already can imagine that the answer is no. This is not a good test, and the reason for this is when you think about what we are testing here, then you will realize that this compute method in the main page view model internally makes use of this calculator implementation that is created up here in the main page view model class, and the actual calculation is done in this calculator class. So what this means is our test does not only test the view model, but it tests both the main page view model and the calculator implementation when we execute this compute method. And this is something that you want to avoid in unit testing. You do not want to depend on multiple units and multiple components at once. You want to test your classes in a very isolated manner. And that means, in this case, that we need to find a way to isolate the main page view model from this calculator implementation to make sure that we only test the view model. One note about why this is not desired. Imagine, for example, that a developer introduces a bug in the calculator class. One of your teammates, the one you don't like anyway, introduces a bug in the add method of the calculator, and you run your unit tests. You're working on the main page view model, and you run your unit tests, and all of a sudden this unit test here fails because the result is not the expected one. But the method only fails because the calculator implementation is faulty, not because you did anything wrong in the view model. So this unit test is not very helpful and very beneficial for testing the view model only. And that also is a nice example of how integrating unit tests into your application often makes you think about what you need to change in your application design to make your code more testable, to increase testability of your code. And this at the same time often has the benefit that not only the testability of your code increases, but when you do these changes to isolate classes, you also improve the overall design of your application itself, Okay. And the way you would usually do that in a situation like that is to use, for example, something like dependency injection. This means that we should try to avoid to create the calculator here in the main page view model directly, but instead we should have the possibility to pass in the calculator to use to this view model from the outside world. I will go through this step by step to give you an idea how to fix these situations and how to design your application in a way that makes unit testing meaningful and useful. The first thing you usually do is you extract an interface from the class you want to use for example, for dependency injection. So I will use a refactor here, the resharper refactoring methods here. You can also do this manually, of course. And what this does is this calculator now implements an iCalculator interface. And when we take a look at this interface, then you will see that it only defines this one single add method. And the second step is to go back to the main page view model, and instead of creating a calculator implementation here, we will change this code to use the interface instead. And now we'll go down here and add main page view model constructor. This is the default constructor that is used when the main page view model is created by the main page. It does that in a SAML directly. I have set up a view first view model creation here in MVVM. And this constructor is used by at runtime by the SAML parser. And what we will do is we will do the same like we did before. We will create this calculator here. In more sophisticated scenarios, you would pass this in from the outside too, maybe use some dependency injection framework or something like that. But for our application, this is perfect. And I will add a second constructor to this view model that takes an iCalculator implementation and uses this implementation instead of creating its own. And this change here allows us to now unit test our code in a way that we can inject a custom calculator into our main page view model. So the test will not depend on the actual calculator implementation anymore. So let's see how this would be done. What I want to do is I want to use the constructor that takes this calculator. So I need a iCalculator implementation first. And I will create this as a private class here. And I will name it fake calculator. Okay. Let's implement this interface, which is the add method. And the important thing is, when you create such fake classes, you do not want to duplicate the functionality that is located in the original classes. For example, I could go ahead and write x plus y here, but that would duplicate the original functionality, and I do not want that. I want to create a very dumb class that does exactly what I want it to, and that does not contain any logic. So what I want to do is I want to add a public field here that I can use to tell this fake calculator what to return, and it should return whatever I have configured it to return. So in this case, it might not be obvious. If you look at the original calculator class, you can see that the actual implementation is only one line of code, and this also is only one line of code. But in a real-world scenario, the calculator implementation, or this implementation of this method here, may be 200 lines of code. And instead of duplicating these 200 lines of code, you would make this as simple as possible and as controllable as possible from the outside world. Okay. Now I have to change my actual test code. I will first go ahead and define the result here that I want to use. And now I create a stop calculator. Stop calculator. And this will be my fake calculator. And I configure it to return the result I have defined. And now, instead of using the default constructor, I pass in my stop calculator here to this view model. And I change this assert down here to check for the result I have passed in. And by doing this, I have isolated the main page view model from the actual calculator implementation. And even if my colleague introduces a very nasty bug into the actual calculator implementation, this test here will not fail because it does not depend on the actual calculator implementation anymore. It uses the fake calculator that I have defined down here. And this test will still pass even if the calculator returns a false result. And that is exactly what we wanted to. for the calculator implementation, I will add a second class, a second test class, and own test methods to make sure that the calculator is working correctly. But this test here should not fail when the calculator has a bug in it. It should only fail when the main page view model has bugs in it. Okay? So that is exactly what we are testing here. Okay, so that was a quick advanced topic of unit testing and isolating unit classes for testability. And you can see that this is a very tedious process. We had to write our own fake calculator class, and if you take a look at the original implementation, you will see that our fake implementation even is larger than the original implementation. And you can imagine that when you use more complex classes, that this can become quite some work to manually create these fake classes and use them as stubs or as mocks to assert against. So usually what we have in unit testing frameworks is some sort of isolation frameworks, which means we can use frameworks that do the work of implementing these iCalculator interfaces, for example, for us automatically. And the problem is, unfortunately, on Windows Phone, all the APIs that are required by such isolation frameworks that do this work for you are not available for various reasons. Either they are not implemented or they are restricted, security restricted. So there are no isolation frameworks for Windows Phone. So if you want to test on the phone, you have to do all this manually. And I will now go ahead and show you a different way of writing your unit tests for Windows Phone that allows you to make use of these isolation frameworks, for example, and other features. And that is to use Silverlight's unit testing, desktop Silverlight's unit testing functionality instead. So what we can do is we can create sample calculator tests.silverlight application here. And unfortunately, I have to do one additional fixing step because for some reason the Silverlight 5 upgrade broke the unit testing template. So what I have to do is, sorry, that's the wrong project. I have to remove these two assemblies here and manually add them. These assemblies are located in the Silverlight toolkit and the Silverlight 5 toolkit, and for some reason the template cannot recognize these assemblies automatically, so I simply add the references in manually here to fix that. Okay, and now we have a Silverlight test project. This test project executes in the web browser, and since desktop Silverlight and the phone Silverlight are very familiar and are from the same family of framework of target runtimes, we can go ahead and add a reference to our sample calculator project without any problems here. The limitation, of course, is that we cannot use any phone-specific features in this Silverlight project, but we can use all of the Silverlight-specific features, which means that you will not be able, for example, to unit test certain UI elements that are specific to the phone. But for me, this is not important because I do not unit test my view components anyway. And what we can do is we can simply copy. Let's copy this view model test view models. Let's copy that over, and if we execute that that Silverlight project now, let's make sure that it is built. And if we start this project now, you can see that we have a very similar UI to the one we have in the emulator, just with the comfort of the desktop. And we can now see that we can comfortably read the method names, and we get basically the same output like on the phone, because after all, this is the same unit testing framework. The phone assemblies are the same, they are just compiled against the phone platform. Okay, and now that we have set up a Silverlight project for this, we can make use of all the possibilities Silverlight gives us. For example, we can go ahead and add one of the isolation frameworks out there. I hope this works. Hitting NuGet Live, for example, using NuGet, searching for the mock framework, which is my favorite isolation framework. It has Silverlight support. And now we can rewrite this unit test. And instead of creating our own fake calculator class here, we can now make use of the mock framework to do this work for us, which means I will go ahead and delete that class entirely. And what I will do instead is I will use a mock object, which is located in this mock library, and tell it that I want to have an implementation of the iCalculator interface. I won't go into the details of the syntax here. I just want to show you that we now can make use of features that are missing on the phone. I will set up this fake class and tell it when someone calls the add method, please return the result I have defined up here. And instead of passing in this mock object, I need to pass in the object property of this mock object. So this basically is the same like writing my own fake calculator class and setting it up so it returns a predefined value, but with only 2 lines of code. That is the benefit of these mocking frameworks. And if I run this now, let's first build it. You can see that it still works in the same way like before, like when we had the fake calculator. Okay, there you go. So this is an alternative. It is a bit of a compromise because you may run into things that you cannot test when you do your testing in Silverlight. You can use additional features like code linking and things like that and try to work around these issues. But usually this already is pretty powerful and allows you to use all the possibilities you have for desktop Silverlight, even for your unit tests for Windows Phone code. So this concludes the live coding session, the first live coding session for unit testing on the phone. Let me return to the PowerPoint presentation. I have a summary which is pretty clear. The setup is not straightforward. We have limitations. We have to download assemblies and do some manual setup here. Writing tests is pretty much the same like with any other application, and it's really challenging for beginners to do this in a good way, so you really benefit from it. And we have learned that mocking and isolation frameworks are not available, and you have to manually do that by yourself, except when you do some tricks like using Silverlight for your unit tests. Which brings me to the demo I was talking about in the beginning. What I want to show you as a live demo, as conclusion to this webinar, is a demo of a phone testing framework created by Stuart Lodge. He has made this publicly available as open source on GitHub. And this brings behavior-driven development to the Windows Phone platform. If you're not familiar with behavior-driven development, then let me explain this for a minute. In unit testing, we very much focus on testing our units and components in a very isolated manner. We have just seen how we, in fact, we have isolated one of the components even more to fulfill this requirement of unit tests. And what we do is we assert against the state of our objects that is under test after we have performed some setup and operations. Behavior-driven testing, on the other hand, focuses more on the behavior, of course, of the application, on the features of application from a different point of view, from a higher level. If you will so, behavior-driven testing is located more on an integration level that tests the interaction of components, but in a way that focuses more on the bird's eye view on your application or on your components. It doesn't need to be the application, the whole application. So, for example, this way of testing would specify something like, I, as a user of this calculator app that we had, I want to start the application. I want to enter some values into the text boxes and hit the compute button, and I expect that a certain result appears on the screen. That would be a test, a scenario, they are named scenarios in behavior-driven design, that would describe a test. And the challenge here is to bring the same degree of automation into behavior-driven design than that what we have in unit testing. So the framework Stuart wrote, or is currently writing, does this. It uses some other frameworks that are already there for behavior-driven development. And what he does is he adds with his framework the possibility to use that from the Windows Phone. So he allows you to write tests that go out and test your phone application in a BDD way. And I want to go ahead and show you what this looks like in a separate project here. Let me bring this in. Okay, so let me close all these open files. And the way this works is you have to do some setup work. Stuart has some excellent videos that show how to set up the projects for this. Basically, it's a one-liner you have to add to your existing phone application. We can actually take a quick look at this. That one here to set up the automation client. And then you have to add a second project to your solution, which is a .NET class library. All the references and all the assemblies required for this are located on NuGet, so you can simply use the packet manager and get all these references into your project. Set this up. You can set this up in a way that none of the testing code will be part of your release version, so none of the testing stuff will end up in the application that is in the marketplace. So very clean setup is possible here. And then you go ahead and write the tests in this .NET application. And how this works is a framework named SpecFlow is used, which uses tests written in something called the Gherkin language, which is free text. We will see that in a second. This allows you to write your tests, your behavior tests. And Stuart's framework will take care of these steps and these tests you write, transform them into code. Behind the scenes, all these frameworks create unit testing similar code that is executed at runtime. And then the framework will go out and actually use these actions defined in the test to interact with the emulator, with the phone emulator. You often see that in behavior-driven development, that some sort of UI automation is used. There are frameworks out there, for example, to test websites, web applications that spin up actual instances of browsers and click buttons automatically and things like that. And Stuart's framework does exactly that for the phone emulator. And we will now see how you write tests for that. These tests are located in feature files, in SpecFlow feature files, and they have a description here at the top, which is not compiled into anything, but is important as documentation. And then you define your scenarios. Each scenario is a behavior-driven test. I'm using a slightly custom version of Stuart's framework. I have changed a bit, but basically this is the same like what you get on GitHub. And the way you do that is you use a language named given, when, then. This is working style language to define what you want to test. So let's go through this for a moment. My first scenario here says I want to correctly add some numbers. And I say, given my app is clean, installed and running, when I enter 2 into the control first number text box, and I enter 3 into the control second number text box, and I press the control compute button, then I see the control result text block contains 5. And take a picture. This is a little gimmick that is really impressive. Stuart added, you can take pictures of the emulator as, for example, as a documentation. So how does this magic work? What happens here is that behind the scenes, these free text formulated tests are translated into code. And for example, something like, given my app is clean, installed and running, will start the emulator. It will install your phone application into the emulator and make sure it is started. And a line like, when I enter 2 into the control first number text box, will go out, find the text box, first number text box in the emulator and put the string 2 into it. Okay. So Stuart has done some great work already and predefined those steps, and you can get the information about these steps from his source code or the wiki pages, hopefully in the future, to get an idea what steps you can use here to define your tests. And let's see how this works. I will actually go ahead and close the emulator to make sure I don't have any side effects from previous tests. The way this is executed is you can use any test runner, any existing test runner to execute these tests. For example, I'm using the ReSharper test runner here. It recognizes the 2 tests I have defined in this feature file. And when I, for example, execute one, you can see that the emulator started. My application is installed into the emulator and started. The values are magically put into the text boxes, the compute button is hit, and the test makes sure that the number 5 appears in the text log. And that's a really impressive way to test your application, isn't it? And in the end, it also took a screenshot of the application, which now is located in the executable folder of this test project. And you can write all sorts of tests in that way and test all the functionality in your application from, for example, a user's point of view. Okay. And one thing I wanted to add is these files here can be treated like normal code files. For example, you can place breakpoints here, and if you execute the test, you will see that the execution of this test will actually stop and hold and break on this line. Okay, I need to debug it, of course, not execute it. And you can step through these tests line by line and inspect the current context of this executing test in a normal featured text file. A very cool way to do your testing. Okay, so let's continue, and the test finishes. Okay, so one last word about BDD is that this usually goes hand in hand with unit testing. This is usually not something that replaces unit testing, but this goes hand in hand with unit testing. There's a very sophisticated workflow. People have thought about how to integrate behavior-driven development into a normal TDD-driven development process, for example, where you would define your BDD tests and then drill down and write your unit tests to make each one of these steps happen and work. And when all of the unit tests required to make these individual steps are done and the implementations are finished, then you will be at a point where the whole BDD scenario will successfully execute and you can move on to the next scenario. That's a very interesting way to develop software, and maybe I will write an article about this workflow and how this applies to Windows Phone applications in the future. So this concludes the webinar on unit testing for Windows Phone, with a small addition on behavior-driven design, behavior-driven development. Let me just bring up the resource site here. I have collected all the resources here. You will receive these links as part of the follow-up of this webinar too, so you don't have to copy them now. One thing I want to explicitly point you to that I did not mention so far is the site of Roy Osharov, who is a guru on unit testing. You don't need to agree with some of his views on the .NET community, but regarding unit testing he has some excellent views and some excellent advice to give. And for example, this best practices video is something you can take a lot from when you have not so much unit testing experience. So I highly recommend watching the videos of his sessions he makes available for free on his site. Okay, so now that's really the end of the webinar, and I hope you enjoyed it and have taken something from it. And as always, if you have any questions left, you can contact me later, and now we will continue to the Q&A session.
Yes, Peter, so thanks for the presentation first. I hope everyone enjoyed the demos. So we have a couple of questions so far. I just want to ask you to read the question first so everyone may hear it and respond to it after that. Okay?
Mm-hmm. Mm-hmm. So the first question is, how can we use unit tests for Windows Phone 7 apps with the Team Foundation Server build service? Good question. I have to admit that I have very little experience with TFS, so I cannot answer this question at the moment. I'm really sorry. I can try to find some resources for you if you contact me offline, but I'm not able to answer this question, if it's possible at all or how it's possible right away. Then we have a second question from Anatoly, which is there any ways to mock service calls in Windows Phone? Well, you can use the technique I have shown in this webinar to mock almost everything. So, for example, for service calls, you would usually wrap your service, your web service, into something that sits in your Windows Phone application. For example, something like a repository pattern if you go out to a web service. And you can, of course, do the same thing we did with the calculator here, which means create a fake implementation of your repository, and instead of using the real one that goes out to the web service, you would use this fake repository to create some test data, some offline test data, and that would enable you to do this isolated testing of your application without depending on the web service. Okay. One question from Samidip. Peter, do the resources point to the special language you demoed in the BDD test? The links I've listed do not point to that language, but if I still have this link even open, I think I will add the link that explains both the concept of links to both the concept of the Gherkin language as well as the concept of having this given, then pattern and what the semantics of this pattern is to the show notes. There are good explanations of these in the projects that have initially invented those languages, which is Cucumber, I think, and SpecFlow.
Okay, Peter. So, okay, just one final question. I'm just right now assigning it. Okay, we have more coming
up. One question from Marius. Does the follow-up contain the PowerPoint presentation? I'm not sure. I thought the PowerPoint slides were sent out already. Maybe Svetla can answer this.
Yes, so the PowerPoint presentation is already available on SilverLight homepage at the top right. You can download the slides, but still all attendees will receive an email with all demos, with the slides, as well as the recording of this webinar. So within one day, you will get all these materials emailed to you. Or you can also find them online tomorrow on SilverLight website. They will be visible on the homepage. Okay, so there's one final from Anatoly.
Yes, which is, can you recommend some BDD recording tools? I guess this is about Windows Phone. So I don't know about any tools that do this at the moment. I think pretty much the framework from Stuart is the only framework that exists for Windows Phone. He's currently working on making this available for iOS and Android too, but it has no recording capabilities, and I don't think there exist any other frameworks for this at the moment.
All right, Peter. So these are the questions we got so far. So if anyone has some other question on mind after the presentation, feel free to drop it in SilverLight forums, and Peter will reply to it after that. So thanks, Peter, for this presentation. Thanks, everyone, for joining us at this time, and we welcome you to complete our survey. It will be displayed just after you exit the webinar, so you can leave any feedback you have on this webinar, any recommendations you have. And 3 of you will have the chance to win Peter's ebook on getting ready for Microsoft Windows Phone 7 exam. Okay, thanks a lot, everyone. Goodbye from me.
Thank you too, all, for joining and for attending, and see you soon. Thanks.
Okay, bye, Peter.
Bye-bye.